So in this class we'll see a few problems on complex numbers. The first one is if x plus iy equals to 1 by 1 plus cos theta plus I sin theta, then show that 4x square minus 1 is equals to 0. So we will consider what is given to us here. We are given x plus iy. Remember the standard form of a complex number is x plus iy. So left hand side we have the standard form. Right hand side also we have to bring this in the form of x plus iy. So what we have to do, we have to consider this 1 plus cos theta as the real term and I sin theta as the imaginary term. Then the conjugate of a plus ib, remember if z is equals to a plus ib is your complex number, then the conjugate of z is written as z bar is equals to a minus ib. So in order to bring the right hand side in standard form, we have to multiply and divide with the conjugate of denominator, that is 1 plus cos theta minus I sin theta by 1 plus cos theta minus I sin theta. So the numerator is now 1 plus cos theta minus I sin theta into 1 when we multiply both the numerators. So we get 1 into 1 plus cos theta minus I sin theta. Denominator is in the form of a plus b into a minus b. So a plus b into a minus b is a square minus b square. So we are using the form a plus b into a minus b is a square minus b square. So we need to keep the numerator as it is and keep on simplifying the denominator. First term is in the form of 1 plus cos theta whole square in the form of a plus b whole square. So a square plus b square plus 2ab minus I sin theta whole square. Both the terms we have to square. This becomes iota square into sin square theta. So this is 1 plus cos theta minus I sin theta whole divided by 1 plus cos square theta plus 2 cos theta plus sin square theta. Remember the value of iota square is minus 1. So here we have minus iota square value is minus, so minus of minus will become plus sin square theta. And we can make use of the identity here and write cos square theta plus sin square theta as 1. So once again we need to keep the numerator as it is. 1 plus cos theta minus I sin theta. Denominator we already have 1. Cos square theta plus sin square theta according to the identity is 1. So this is 1 plus 1 plus 2 cos theta as it is. So remember we have x plus iy on the left hand side. So right hand side we can write as 1 plus cos theta minus I sin theta by the denominator 1 plus 1 is 2, 2 plus 2 cos theta. So what else we can do is we can keep the denominator by taking out 2 common. We can write the denominator in the form of 2 into 1 plus cos theta. So let us take 2 common from the denominator. This is 2 into 1 plus cos theta. Now we can separate first term by denominator minus second term by denominator. So 2 into 1 plus cos theta. So we have separated first term by denominator minus second term by denominator. Here 1 plus cos theta, 1 plus cos theta you can eliminate. And here you can write this as I into minus. You can take inside the brackets and write minus sin theta by 2 into 1 plus cos theta. So left hand side is in the form of x plus iy. Right hand side also you can write in the form of x plus iy. So you need the value of x square, 4x square minus 1. So let us equate the real terms on both sides. Equate the real terms or the real parts on both sides. We get x equals to 1 by 2. So if you cross multiply this, we get 2x equals to 1. By squaring on both sides, we can write 4x square equals to 1. Finally, we can say 4x square minus 1 is equals to 0. So our next problem is if x plus iy equals to 3 by 2 plus cos theta plus I sin theta, Then we are asked to show that x square plus y square is equals to 4x minus 3. So as in the earlier problem, let us consider the given term. What is given to us is x plus iy. X plus iy is equals to 3 by 2 plus cos theta plus I sin theta. So remember, 2 plus cos theta is a real term. Once again, to bring the right hand side in standard form, in x plus iy form, we need to rationalize the denominator. So we will multiply and divide with the conjugate of denominator, that is 2 plus cos theta minus I sin theta by 2 plus cos theta minus I sin theta. So we can multiply the numerators, 3 into 2 plus cos theta minus 3 into I sin theta, by denominator as always is in the form of a plus b into a minus b, which can be written as a square minus b square. So 3 into 2 is 6, 3 into cos theta is 3 cos theta, this is your real term, minus 3 into I sin theta. By denominator, let us expand using a plus b whole square. A square is 2 square, b square is cos square theta. 2ab is 2 into 2 cos theta, that is 4 cos theta, minus iota square into sin square theta. So we can write 6 plus 3 cos theta minus 3I sin theta by 4 plus cos square theta plus 4 cos theta. Remember, we have iota square here. Again, we need to use the value of iota square as minus 1. So minus of minus will become plus sine square theta. So we can write cos square theta plus sine square theta as 1 in the denominator. Numerator is written as it is, 6 plus 3 cos theta minus 3I sin theta by 4. We already have 4 here, plus cos square theta plus sin square theta is 1. So 4 plus 1 will become 5, 5 plus 4 cos theta. Now we will bring the right hand side also in the form of x plus iy. So let us separate first term by denominator, 6 plus 3 cos theta by 5 plus 4 cos theta, plus we will take this minus 3 inside, we keep as it is I, minus 3 sin theta by 5 plus 4 cos theta. So as left hand side, right hand side is also separated, first term by denominator minus second term by denominator. Only thing is, instead of writing minus I, we wrote plus I and minus 3 sin theta inside the brackets. Now we need to equate the real and imaginary parts on both sides. Equating the real and the imaginary parts on both sides. The imaginary parts, or you can also say the imaginary terms on both sides. What do we get? We get the real term x value as 6 plus 3 cos theta by 5 plus 4 cos theta, and the value of y comparing on both sides is minus 3 sin theta by 5 plus 4 cos theta. Now the requirement is to show that x square plus y square and 4x minus 3 both are equal. So let us take down the left hand side here. Left hand side is x square plus y square. So let us square and add both x and y. So this is 6 plus 3 cos theta by 5 plus 4 cos theta whole square, that is x square, plus y square is minus 3 sin theta by 5 plus 4 cos theta whole square. So we can separately apply square for both numerator and denominator. We can write 6 plus 3 cos theta whole square by 5 plus 4 cos theta whole square. Same way here, when we square, minus square will become plus, 3 square will be 9, sin theta whole square will be sin square theta by 5 plus 4 cos theta whole square. So you can see the denominator is same for both the terms, so we can keep the denominator as it is, 5 plus 4 cos theta whole square, Let us expand the numerators. A square is 36, b square is 3 cos theta whole square, 3 square is 9 cos theta whole square is cos square theta, plus 2ab, 2 into 6 12, 12 into 3 is 36 cos theta, plus 9 sin square theta. So we have 36, here we have 9 cos square theta, and here we have 9 sin square theta. So we can take out 9 common. We have cos square theta plus sin square theta, plus 36 cos theta is still available in the numerator. Denominator is kept as it is. 5 plus 4 cos theta whole square. So cos square theta plus sin square theta is 1. Cos square theta plus sin square theta is 1. So we can write this as 1. 9 into 1. So your term now becomes x square plus y square is equals to 36 plus 9 into 1, because cos square theta plus sin square theta is 1, plus 36 cos theta divided by 5 plus 4 cos theta whole square. So 36 plus 9 becomes 45, 45 plus 36 cos theta by 5 plus 4 cos theta whole square. Now 36 and 45 both are multiples of 9, so we can take out 9 common. We have 9 into 5 45, 9 into 4 cos theta is 36 cos theta divided by 5 plus 4 cos theta whole square. So you can cancel 5 plus 4 cos theta and this square. So the value of x square plus y square will be 9 by 5 plus 4 cos theta. So this is your left hand side value, x square plus y square. Separately, now we will consider our right hand side. Our right hand side, we have to show that 4x minus 3 is also equals to 9 by 5 plus 4 cos theta. So let us write 4 into x value. X is, remember, 6 plus 3 cos theta by 5 plus 4 cos theta minus 3. This we can also write 4 into 6 24, 4 into 3 is 12 cos theta by 5 plus 4 cos theta minus 3. 3 can also be written as 3 by 1. So let us take the LCM of the denominator. 5 plus 4 cos theta into 1 is 5 plus 4 cos theta. Then we need to cross multiply 1 with this term and 5 plus 4 cos theta with 3. So 1 into 24 plus 12 cos theta minus 3 into 5 plus 4 cos theta. Remember, we are cross multiplying. One is going this side and this term is coming with 3 on the other side. So we have 24 plus 12 cos theta minus 3 into 5 is 15, minus 3 into 4 cos theta is minus 12 cos theta, whole divided by 5 plus 4 cos theta. So plus 12 cos theta minus 12 cos theta we can cancel. 24 minus 15 is 9. 9 by 5 plus 4 cos theta. This is the value of 4x minus 3. Let us take this as equation 1. Hence, from equation 1 and 2, we can say that x square plus y square and 4x minus 3 both are having same value, so they are equal. So the next problem now here is, find the real values of theta. Find the real values of theta in order that 3 plus 2i sin theta 3 plus 2i sin theta by 1 minus 2i sin theta is a two cases we need to consider. If the number is a real number, what are the real values of theta, and is a purely imaginary number. purely imaginary number. So again we need to go back to the basics. So what is given? We will consider the given complex number. The given complex number is 3 plus 2i sine theta by 1 minus 2i sine theta. We need to bring this in the standard form. Remember, our standard form is x plus iy. So to bring in standard form, we need to multiply and divide with the conjugate. Conjugate of 1 minus 2i sine theta is 1 plus 2i sine theta. So a plus ib conjugate is a minus ib, a minus ib conjugate is a plus ib. So 3 into 1, 3 into 2i sine theta is 6i sine theta. Then 2i sine theta into 1 is 2i sine theta plus 2i sine theta into 2i sine theta is 2 into 2, 4i into I iota square, sine into sine, sine square theta. Whole divided by the denominator again is a minus b into a plus b, that is a square minus b square form. So we need to write a square minus b square. So this is 3 plus 6i sine theta plus 2i sine theta becomes 8i sine theta. This becomes minus 4 sine square theta because of the value of iota square is minus 1. Here we have iota square. This iota square we are using as minus 1. So 4 into minus 1 becomes minus 4. Whole divided by 1 minus 2 square 4 iota square sine square theta. So we can write 3 minus 4 sine square theta plus 8i sine theta by, again we can make use of the iota square value in the denominator as minus 1. So this minus and this minus will become plus. So we have 1 plus 4 sine square theta. Let us separate the real terms by denominator. 3 minus 4 sine square theta by 1 plus 4 sine square theta. This is the real term plus I into 8 sine theta by 1 plus 4 sine square theta. So remember, this is in the form of x plus iy. This is in the form of x plus iy. So for, if the number is purely real number, if it is a real number, if it is a real number, that means if the given complex number is a real number, that is possible only if the imaginary part is that is possible only if the imaginary part is 0. So whenever we say that it is a real number, we need to consider that there is no imaginary term. The imaginary term should be 0. When the imaginary term is 0, then only the real number, then only it will be a purely real number. So for this number to be a purely real number, the imaginary term should become 0. What is the imaginary part? 8 sine theta by 1 plus 4 sine square theta should be equals to 0. You cross multiply, you get 8 sine theta equals to 0 or sine theta equals to 0. Remember the general solution we have: sine theta equals to 0, theta equals to n pi, n belongs to z. This is the general solution of sine theta equals to 0. So we can write theta equals to n pi. Whereas the second case, it is a purely imaginary number. The given number is purely imaginary. This is possible only if there is no real term. So purely imaginary number implies the real part should be equals to 0. So what is the real part? 3 minus 4 sine square theta by 1 plus 4 sine square theta should be 0. Cross multiply, you have 3 minus 4 sine square theta equals to 0. 3 equals to 4 sine square theta, or you can also write sine square theta equals to 3 by 4. Just a bit of manipulation, we can write this as root 3 by 2 whole square for 3 by 4. So we have sine square theta equals to root 3 by 2, we can write as sine 60. The square will be as it is. So we have to use the formula sine square theta equals to sine alpha, theta is n pi, plus or minus alpha, where n belongs to z. This is the formula you have to use. Sine square theta equals to sine square alpha, theta is n pi, So sine square theta equals to sine square alpha, theta equals to n pi plus or minus alpha, where n belongs to z is the formula which we have to use here. So the next problem is, if x and y are real numbers such that 1 plus I into x minus 2i by 3 plus I plus 2 minus 3i into y plus I divided by 3 minus I is equals to I, then determine the values of x and y. So we are given 1 plus I into x minus 2i whole divided by 3 plus I plus 2 minus 3i into y plus I whole divided by 3 minus I is equals to I. You need to solve this problem very carefully. First of all, let us open up the numerator. 1 into x plus I into x minus 2i by 3 plus I. We are making the numerator simple by avoiding the brackets. Then 2 into y minus 3i into y plus I is alone whole divided by 3 minus I is equals to I. Now let us add these two numbers on the left. The numerator, the denominator will be the product of denominators will be the LCM, 3 plus I into 3 minus I. So we need to cross multiply. This will go with x plus ix minus 2i into 3 minus I, plus this term should come with the other term on the right, 2i minus 3iy plus I into 3 plus I is equals to I. So let us now multiply first 3 minus I. Will multiply both the terms with x. X into 3, x into minus I. Then ix into 3 is 3ix. Ix into minus I is minus I square x. Minus 2i into 3 is minus 6i. Minus 2i into minus I is plus 2i square. Now the second term. 2y will multiply with 3. 2y into 3 is 6y. 2y into I is 2iy. Then minus 3iy into 3 is minus 9iy. Minus 3iy into plus I is minus 3i square y. I into 3 is 3i and I into I is I square, iota square, that is. So whole divided by denominator is in the form of a plus b into a minus b, which is again a square minus b square, equals to, remember we have I on the right side. So now what we can do, we can see wherever what we can do, we will see 3x. Here we have 3ix minus ix, so we can write 2ix. Iota square value, don't forget, is minus 1, so minus of minus will become plus x. Minus 6i, again iota square is minus 2 into minus 1 is minus 2. This is 6y. 2iy minus 9iy is, we can write this as minus 7iy. Then iota square is minus, so minus into minus will be plus. So let us make it a bit clear. We have 2iy minus 9iy. 2 minus 9 is minus 7iy. Then iota square is minus, minus into minus becomes plus 3y plus 3i, and iota square is minus 1 whole divided by, we have 3 square minus iota square, 3 square is 9, iota square is minus, so minus of minus 1 is equals to I. Now what best we can do is, we can separately add up the numerators where we have real terms. 3x plus x is 4x. We have 6y plus 3y is 9y. Then constant terms minus 2 and minus 1 minus 3. So these are the terms, real terms, where we don't have I. Then the other terms with I, let us write down. I with have 2x, let us take I common, 2x. Minus 6i, I is taken common, so minus 6. Minus 7iy, I is taken common, so minus 7y. 3i plus 3 is, we can write I is taken common. So denominator is 9 minus of minus 1, 9 plus 1 becomes 10. 10 we will cross multiply and write this with the right hand side where we have I. Okay, so we can now make it more simple and write 4x plus 9y minus 3 plus I into 2x minus 7y minus 6 plus 3 is minus 3 equals to 10i. 10i we can write as 0 plus I into 10. So both the sides are in the form of x plus iy. Both the sides are in the standard form in the form of x plus iy. Now we will equate the real terms and the imaginary terms. Equate the real and imaginary parts or imaginary terms on both sides. So remember, the real term is 4x plus 9y minus 3 left hand side, and there is no real term here, it is 0, whereas the imaginary term is 2x minus 7y minus 3, and on the right side the imaginary term coefficient of I is 10. So this we can write in the form of an equation equals to 0. Same way we can write this as 2x minus 7y minus 13 equals to 0. We are taking plus 10 that side, it becomes minus 3 minus 10 minus 13. Now using cross multiplication method we will find x and y. So by cross multiplication method, this is the simple method when compared to the elimination method. For cross multiplication, first we need to take the coefficients of y. So 9 from first equation minus 7 from second equation. Then the constant terms minus 3 from first equation minus 13. Then the coefficients of x4 from first equation, 2 from second equation. Again you repeat the coefficients of y. Now you have to take a pair of 4 and 4 together. So these two you have to take 1, 2, 3, 4 AD minus BC form. We have to write this AD minus BC. So what will be 13 into 9? This is minus 117. Okay, minus AD minus BC, minus 7 into minus 3 is plus 21. So minus 117 minus 21 is equals to, now take these 4, y by AD minus 3 into 2 is minus 6, minus BC minus 13 into 4 is minus 52. This is equals to, again the last 4 you take together, this is considered as constant. 1 by AD minus BC, 4 into minus 7 is minus 28, minus 9 into 2 is 18. So we have x by minus 138 equals to y by 52 minus 6 is 46 equals to 1 by minus 46. Okay, now you need to bring up the proper pairing x and the first and the last one, second and the last one, and you need to solve. So what is that we will have now? Let us see. So x by minus 138 is equals to 1 by 46, and y by 46 is equals to 1 by 46. Okay, if you want to check out you can just go back and check out. Here it is 1 by minus 46. So this is 1 by minus 46. So both we are equating. Now x will be equals to minus 138 by minus 46. That is x will be equals to 46, I think goes 3 times. So x equals to 3, whereas y equals to 46 by minus 46. 46, 46 you can cancel, 1 and minus sign will be remaining. Therefore, the value of x is 3 and the value of y is equals to minus 1. So now let us see how to find the square root of a given complex number. Remember, the square root of any complex number a plus ib is given as plus or minus under root of a square plus b square plus a whole divided by 2 plus I into under root a square plus b square minus a whole divided by 2. When you have plus in the middle you will write plus here. When you have minus in the middle, if it is in a minus ib form, then you have to use minus I into root term. Remember, when it is a plus ib form, the middle sign will be plus. When it is a minus ib form, the middle sign will be minus. This we can also write as plus or minus under root of mod z plus a by 2 plus I into under root of mod z minus a by 2. Remember, mod z is the modulus of a complex number. Mod z is equals to under root of a square plus b square. When the complex number is in the form of a plus ib, we can write the modulus as under root of a square plus b square. So our given complex number is minus 5 plus 12i. Okay, so let us take this as z. Let z equals to minus 5 plus 2i. We will find the modulus of the complex number first. So this is under root of a square plus b square. That is under root of 5 square is 25, 12 square is 144. So 144 plus 25 is 169. Root 169 can be written as 13. Therefore, let us find the square root of this complex number. Minus 5 plus 12i is equals to plus or minus under root of mod z plus a by 2 plus I into under root of mod z minus a by 2. So plus or minus under root of mod z is 13. A value is minus 5. Remember, when you're comparing this with a plus ib, you have to remember the value of a is minus 5 and the value of b is 12. So this is by 2 plus I into under root of mod z minus of a is minus 5 by 2. So this is equals to plus or minus, this becomes 13 minus 5 is 8, 8 by 2 plus I into 13 plus 5 is 18, 18 by 2. So you can do the bit of cancellation here. Root 8 by 2 is root 4 and 18 by 2 can be written as 9. So we all know root 4 is 2 and root 9 is 3. So 2 plus I into 3, which we can also write as 2 plus 3i. If you want to verify whether the square root of your given complex number is right or wrong, you just for verification you need to find what is 2 plus 3i whole square. Just expand 2 plus 3i whole square using a plus b whole square formula. A square plus b square plus 2ab, 2 into 2 into 3i. So this will be equals to 4 plus 9i square plus 4 into 3 is 12i. This is 4 minus 9 plus 12i. Remember, the value of iota square is minus 1. 9 into minus 1 is minus 9. So 4 minus 9 is minus 5 plus 12i. That is how you can verify whether the square root, the value which you got, is the right one or the wrong one.